喂。哎，那个隔壁的同步啊，那有这个，好。Okay, so it's about time. Yeah. So before we start, I noticed that we have probably more people than seats in this room. So let me just explain that we actually reserved 2 rooms. One is this room. This room will be called the main room. So in here, I would like to make a request once and for the entire semester. In this room, in class, 上课时间 in class, please, I ask you not to eat or drink, and the only exception is water, H2O. Okay, so that's in this room. Yeah. But in the meantime, I understand that this is shortly after lunchtime, and it's beginning of a semester. A lot of times, the restaurants are all full of your fellow students, so it's hard to get to finish your lunch before class. I understand that. Okay, so if you need to eat or drink or do anything, you please go to the next room down this way. Okay, so all the lectures are going to be synchronized, broadcasted from this room to the next room, so you will be able to just receive the lectures in a more relaxed way while eating, or even, I don't know, talking to your classmates, criticizing the professor in the next room, but not this room, okay? So in this room, please, no food or drink, okay, except water, right? Is that clear? Can we agree on that? Can we try to agree on that? So in the meantime, so people in the back, you are welcome to try to go to the next room, or you may also stay. It's fine. Yeah, it's fine. You can stay, or you can try to experience the next room, right? Okay, good for you. Thank you. Either way, right? Okay, so let's start. This is EE 3660, Introduction to Digital Signal Processing. And my name is Yiwen Liu, my Chinese name, Liu Yiwen. We are at the Electrical Engineering Department of this university. And a bit about myself. So I got my PhD degree exactly 20 years ago, in January, actually. So that's where I got my PhD from the EE department at Stanford. And my thesis, since my PhD time, I've been working on signal processing. So my thesis topic was about audio watermarking. Audio is signal processing, okay? 音讯 audio, that's my specialty. And since then, I did 4 years of postdoc training somewhere in America before I came back here in 2010, where I started my position at NTHU in 2010. And over the past 16 years or so, I've taught quite a few courses, for example, probability and linear algebra 4 times, 5 times, right? And I also taught PDE and complex analysis 3 times, and PDE numerical method for 2 times. And also, this is going to be the 6th time I'm offering this course, Introduction to DSP. But in the meantime, in a few years, in some other years, I offered DSP, digital signal processing. I offered the graduate level, 研究所的. I also offered a graduate level DSP in the past 7 times. And I have my own graduate level course by the name of, it's about audio signals, more than 10 times, that's my specialty. And I also just taught some other courses in the past. So that's a bit about myself. And so that's an error. So let's first talk about, so in this next about half an hour, I'd like to go through the course requirement and what DSP is about, okay? So the first thing is about, what I just said. We'll meet at room 206, that's here, but this is incorrect. Okay, please, that's an error. So our overflow room for this year is this room, not that room. Anyway, so this room, the room in that direction, not 207, but 205. And we'll be using synchronous broadcasting. And one room, this room is the main room. The other room is the overflow room. And lectures, all the lectures we promise you will be recorded. And video will be edited and shortly available after the class, okay? After class every week. So that's that. And the way I'm going to offer my lecture is a mixture of PowerPoint presentation. Actually, not PowerPoint, but like screen presentation. I'm going to use this main screen all the time, while sometimes I will write on the blackboard. Okay, so both will be used. And also, lecture notes will be available beforehand, so including the welcome message as well as the first and second lectures. You should be able to download it, find them on EE class. Okay, it's already there, so those of you with your tablet or your iPad, please feel free to download the lecture notes from EE class, right? And what are the prerequisites for this course? I would say you need to know calculus, for sure. You need to know how to perform integral by hand, 积分嘛, and you also need to be, you're supposed to be familiar with complex numbers, complex number x plus yi, complex numbers, imaginary part, real parts. And if you are from, I think the majority of you are from EE department, okay, or ECS, 电子院学士班. Okay, so are you from ECS? The immediate prerequisite, the most relevant course, most important course before DSP, I would say is signals and systems. So if you have taken signals and systems, you are ready. Okay. Simply put, so if you have taken signals and systems, you are ready. But if you haven't, but somehow you've managed to learn these concepts by yourself, you are ready. Okay, so if you already know what is Z transform, you are very much ready. If you already know what is the convolution and what's the application scenarios, if you already know delta function, that's good. If you already know Fourier transform, you should be okay. You should survive. Okay, so that's a prerequisite for digital signal processing. And so with that, let's talk about then what roughly or exactly is DSP. What is DSP? I'm showing a workflow right here, but I want to say that before we jump into the workflow, DSP, I actually found it pretty hard to define what is DSP. What is signal processing? What is digital? Well, digital is a simpler question to answer. What is digital? Zeros and ones, digital systems. But what do you mean? What do we mean signal processing? That's a hard question to define. That is very hard to define that. Why? Because both the word signal and the word processing are vague. Right? What do you mean signal? Anything that changes in time can be called a signal. And what do you mean processing? Processing is like anything you make, anything you do is a process, right? Food processing is processing, right? So when we say processing a signal, it's actually pretty vague or pretty broad, right? It's not like bike maintenance, 修脚踏车, it's very specific, right? That's very specific. You maintain, you fix a bicycle, that's very specific. But when you say you process a signal, that's not very specific. Can you agree with me, right? So it's hard to define what exactly is signal processing. What is the field generally about? But just trying our best in this course, fortunately or unfortunately, in this course we are mainly talking about this workflow. So let me explain. So we will start by considering a signal, indeed, something that changes in time, where T stands for time, okay? Something that changes in continuous time. And then, for some reason, we need to first, while the signal is still in the continuous time or analog domain, we recommend you to use a filter, a low-pass filter, to pre-process the signal, so to avoid what is called aliasing. So we explain that. So after the anti-aliasing filter, now you have another signal that's still in analog, still in continuous time. Then you just use a C to D converter, where C stands for continuous and D stands for discrete. We'll convert the signal from continuous time to discrete time. That's called a C to D converter. And in doing that, you need a sampling period. Okay, you need to define how often you look at the signal. I will explain that. So then, after that, we are entering the discrete time domain, where the time index becomes integers. Here, x of n is 1, 2, 3, 4, 5 integers. Okay. All right. So that being said, in this entire semester, we are mainly going to focus on this part. Now we have a system which receives an input in discrete time and produces an output also in discrete time. So this is our main focus. That's what we define as digital signal processing inside this block, okay, inside this box. And then if you're happy with your result, the output, then in some scenarios, you might want to convert your output back to the continuous time domain using the opposite, right? Using a D to C converter, right? So now the entire workflow begins with an analog signal in time, and it also ends with an analog signal in time, where R stands for reconstruction. Yeah. So that's the main overflow for the entire semester. Okay? That's what we are going to focus in this semester. And in particular, we are going to heavily use this equation. So please take a look. Okay? We will spend a lot of time just to study and to design this equation. Okay? So this equation, you will take a look, where yn is right here, yn is right here. Okay? It's the output that your system is supposed to produce. But how do we produce it? We will look at the input, of course, and form a linear combination, where the bk and ak coefficients are constants. Okay? We'll look at the samples in the past. We're going to look at up to n samples in the past, 过去的 n 个 samples. And then form a linear combination. And then there's another term which look at the output the system already produces. Okay? We're also going to look at the output the system just produced over the m samples in the past. And then sum them all up. And then the result is the output for the current sample. It's what we need to compute and produce for the current time. Okay? So this is called a difference equation. And in Chinese, it's called 差分方程式. Okay? So we are going to study this a lot. Okay? So please be prepared that we will study this a lot. Okay? We are going to study how to analyze the performance if you are given the coefficients. Or the opposite direction is that you might be given some specification, some performance specification, such as the bandwidth, the frequency response, and you are going to design the system in terms of this difference equation. Okay, so this course is really a lot about using and about this difference equation. And so that's traditionally how DSP is defined. I call it a classic workflow, 经典的 or classic old-fashioned, 20th century. 20th century digital signal processing is all about this workflow. Okay, so far so good? 20th century. But you guys are born in this century, right? I suppose that most of you were born in this century, 21st century. Unfortunately, nowadays, oh, this is a bit off. Yeah, anyway, right, so now the workflow is heavily influenced by AI. Okay, so just to kind of to compare, I said nowadays signal processing is really a lot about what we call information retrieval and or content generation. If you go to any like IEEE signal processing conferences, okay, most of the people they do over there, we all use AI. Okay, so in the context of signal processing, how is our field influenced by AI? I would say let's take a look. First of all, still from analog to digital, that's nothing has changed much. But from here, you might want to compute some kind of representation using some kind of mathematical transform. Okay? To represent your signal first, and then feed that representation to your AI. Okay? And the AI's job might not be to produce a signal. That could also happen too. But AI's job a lot of times is to retrieve information from this representation of your signal. For example, if your signal is in the audio domain, your AI might look at the representation and try to answer, is this Mozart's music? Or your AI may look at the representation and try to say, oh, this is about heart, cardiogram, ECG, about biophysical signals. And then your AI's job might be to answer, does this ECG look normal? Is there any heart problem? Now we're looking at the signal, right? So that's called information retrieval. We're trying to tell what's going on. And also, or if your signal is in 2D, is a video recording of the atmosphere over Taiwan, right? The AI's job, after looking at the representation of your video recording, maybe the AI's job is to answer, will this typhoon hit Taiwan in 2 days, in 3 days, or next week, right? So that's a lot. There are a lot of topics that AI can help. And so that's, but these are all about information retrieval, trying to answer questions. But on the other hand, sometimes AI's job is not to begin with a signal and to produce a signal, but to begin with some kind of prompts and then produce a signal. And we call that content generation, right? So for example, text-to-speech conversion, okay? Your input is text, the output is AI talking, AI singing, something like that. And moreover, your prompt might not necessarily be text. Your prompt could be itself a signal using music to search for music. Or it could even be a video, a video recording, and AI would just recommend the music that's best suit your video, the video that you just created. Or your prompt could be text. 从现在开始你母语是阿拉伯语. Okay, so nowadays, AI heavily influences the field of signal processing. So that's why I said unfortunately. Unfortunately, all you're going to learn is this classic 20th century workflow. So be patient. There's still some value to study old-fashioned stuff. But that being said, so now, since we just mentioned representation, right? So here, in this course, you are going to become comfortable with Fourier transform. That's the most classic representation for time domain signals, okay? So just to take a look, if you haven't taken a look, so here we have the definition of the continuous time Fourier transform. FT stands for Fourier transform. You will be taking the signal in time and then check out how much the signal and decompose the signal into the frequency domain, okay, by performing this integral. Basically, where this can be also looked at as a inner product. Okay, we are going to multiply your signal with this e to the minus j omega t. Okay, with that, this term will show up a lot. So where omega is the frequency. Okay, omega is the frequency, and then so the result after this integral, your signal goes from time domain to the frequency domain. And a lot of time we call the frequency domain result, we call it a spectrum, 一个频谱. Going from time domain signal, frequency domain spectrums. Okay, so that's the continuous time Fourier transform. But in this course, since we have C to D, we convert our signal to discrete time. And we handle our signal in discrete time. So just, it's not surprising that we also have sort of a version of Fourier transform for discrete time signals. So similarly, the idea is that an inner product. You're going to multiply your signal with e to the minus j omega n, but now we use a small omega, okay, where n's are integers. So now instead of performing an integral, you perform a summation. And the result is very similar. We go from time domain to frequency domain, resulting a discrete time version of a spectrum. Okay? All right. So we are going to go back to this definition quite a lot. And there are a few purposes I can mention. So because why do we need to learn discrete time Fourier transform? Because we are going to, later we're going to touch on system design. What kind of system? We are going to study linear and time invariant systems. And it turns out that these systems are fully characterized by impulse response. And with impulse response, you can use this definition to see what's the frequency response of your system, the system that you design or now analyze. Okay? So the main purpose really is to study a system, how the system does to a signal, frequency response. So that's why we need to study discrete time Fourier transform. And later in this semester, we're also going to introduce a few different versions of Fourier transform. One has a very similar name. It's called the discrete Fourier transform. And a version, the fast version of it is called FFT, the fast Fourier transform. And also there's another version of Fourier transform by the name short time Fourier transform. So we are going to cover all these different styles, different versions of Fourier transform. So next, I'd like to just tell you our textbook. The textbook that I recommend is written by Oppenheim Schaefer, two professors at MIT a long time ago. And this is going to be the third edition of their textbook called by the name Discrete Time Signal Processing. Okay? And just over the years, I've been focusing on a few chapters. We're going to mainly focus on these three chapters. Okay? Going to mainly focus on 4, 5, and 7. While we are going to, in this semester, we will also touch a bit on some other chapters from 6 to 10. Right? So that's mainly our coverage will be these chapters. Is that clear? For the first three chapters, for the first chapter 2 and 3, we are not going to cover in details, because if you take a look at the textbook, those are pretty much the same materials that you have learned from signals and systems, or equivalent to signals and systems. So this year, over the years, I've been just jumping right into chapter 4, mostly jumping right into chapter 4. So yeah, so we'll see how that goes. So far, so good? Yeah? Is it all right? Is it all right? So next, in the next few slides, I'm going to share with you how we are going to run, how we are going to manage this class. Okay? The first thing is, since this is a 3-credit course, so we have 2 hours on Wednesday and officially 1 hour on Thursdays. Okay? So in most of the weeks, starting next week, we are going to organize our class, our lectures into lectures and discussions. Okay? So all the Wednesdays are going to, on a regular Wednesday, I will give 2 hours of lectures. But for Thursdays, starting next week, not tomorrow. Okay, tomorrow I'm still going to give a 1-hour lecture, right? But starting from next week, we are going to do all discussion. All the Thursdays are mostly going to be discussions. And there will be two kinds of discussion sessions. One is called FUD, follow-up discussions. And the other are going to be called homework discussions. Yeah. And also, Thursday discussions, over the year I found that is good for all of us if we offer 1 hour of English followed by 1 hour of Chinese. Right? We're going to discuss the same materials, but I will offer 1 extra session in Chinese. Okay? So if you feel like you feel more comfortable to discuss stuff in your native language, in Chinese, please feel free to come to the second hour. But otherwise, we try to do the first hour entirely in English. Okay? So if you attend the first hour, be prepared that if you volunteer to show your solutions on stage, please explain your answers, your thoughts in English. Please expect that. I'm making this request because I know that we have a few international students in the classroom, quite a few, maybe 7. Yeah. So for the benefit of everybody, the first hour discussion session is going to be in English, and then we switch over to Chinese. Okay? Now, is that clear? Now, please choose one to attend. Right? Now. And here is a tentative schedule. And this schedule, I think we need to post this after class, right? Because sometimes it's hard to strictly stick to the schedule. Sometimes the plan can be modified. But for now, I'd like to show you that this is our schedule, and be aware that we have a midterm, first midterm, second midterm, as well as the final exams. And so just to mention that if you are enrolled in this course with X class, this is an X class. For those of you who are from NTHU, X class means that you sign up for X class, you can simultaneously choose attend another course. Okay? We can do that because we record all the lectures. Not the Thursday's discussions, though, so we will come back to that. So anyway, so this is the schedule. So if you're on X class, please be sure that we need to follow the university regulation in that you need to come in person. You need to attend the exams in person. X class cannot be used as an excuse, okay? So please, if you're on X class, please promise me that you will show up, promise me and my teaching team, that you are going to show up in person for the exams. They will not be rescheduled, okay? They will not be rescheduled. Is that clear? Yeah? Any X class in the classroom? They already go elsewhere. That's good. That's why we will offer X class. Any question regarding the schedule? So we break down into Wednesday lectures and our Thursday plan. So then tomorrow will be a short lecture of 1 hour. Okay, tomorrow will be 1 hour. But starting from this one, homework 1, right? We'll spend 2 hours. First one in English, the second one in Chinese, starting next week when we discuss homework 1, right? Now, so I think my next slide is about how to motivate everybody to participate in the Thursday discussions. Right. So it's pretty straightforward. The Thursday discussion will account for 7% of your final grade, and you will earn 2% for each time you show up here to solve the problems. Okay? Each time when you come to the stage and show your solution, that will give you two points for the entire semester. As well as in each session, if after this person presents his or her answer, if you feel that you want to comment, or you want to point out there's some error, or you want to express your opinions in general, for each expression of your opinions, you will earn 1 point. If you ask questions or comment on other solutions. But in each session, 1 per session, not 1 per question. Okay, please do not expect I will ask 7 questions to fully obtain the 7 points. No. Each session with a maximum of one point per session. Any question regarding this rule? 2 points for each solution, each time you come up on the stage. 1 for asking questions. Any comment or any question? So I asked the TAs to, yeah, please. What? Yeah. So of course, yeah, that's a very good question. Maybe I should give you 1 point. No. Starting next week. So homework, of course. Homework discussion is about discussing the homework. So the homework questions will be announced 1 week before the discussion happens. Okay, 1 week in advance. So that being said, probably tonight I will announce homework 1. It's ready. Because next week we're going to discuss homework 1, right? It's a short one, only 2 questions, okay? Yeah. But then you might wonder, what do I mean follow-up discussion, right? Let's go back to the previous slide. There are also going to be follow-up discussion sessions. So by follow-up, I mean that sometimes in DSP, you'll realize that a lot of times there are some more tedious or deeper mathematical derivations, okay, which are more challenging to go through in class, okay? So a lot of times I will move those tricky questions to follow-up discussions, okay? So they will also be announced at least 1 week before. So for those sessions, if you come into the classroom and this week we're doing follow-up discussion, FUD 1, 2 weeks from now, okay? So I will show you probably in this week, I will announce what are the questions for discussion on FUD sessions. Is that clear to you? FUD, okay, yeah. Actually, I have an example of FUD questions, but let me first go through this slide, okay? I'll show you an example of FUD question in the next slide, right? So I counted, there will be in total 11 sessions for this semester. And I just did a rough calculation. If we can have 10 people on stage every Thursday, then we are going to give out more than 100 opportunities to earn 2 points. Is that clear? Yeah. So, and 2 years ago, because the class size this year is roughly, I expect maybe a bit less, but roughly the same as 2024, 2 years ago. And in that year, 99 out of 156 students score at least 1 point. So I think it works. Okay, if you don't want to say anything, yeah, fine. Yeah. But if you do, so 2 years ago, almost 100 people at least get 1 point. Yeah. And actually, 44 of them score 6 points. Okay. In that year, the full participation is 6 points. This year, I increased it to 7. Okay. This year, I increased it to 7. And some technical details, the TAs, because then how do we decide who come onto the stage, right? To be fair, what if everybody wants to show up? Then we need a mechanism. So in the past, I've been asking TAs to open a link for sign up, right? A web page for sign up. And so we'll figure out the detail. And to sign up, so after you sign up, if more people sign up for the same questions, we'll do a random draw. Okay, we use a computer to do a random draw. And what? If too many people, yeah, the second point, if too many people sign up for the same question, the selection will be random. And then to go with that, those who haven't showed up on the stage will get higher priority. Please trust us. Okay, we try our best to be fair. But in case there's something doesn't go quite right, please report to us. Please give us some feedback and comment. Right? But that's how things work during the past 2 years. Okay, those who haven't showed up on stage are encouraged. Okay, to break through. Right? To break through. So yeah, so they will be given slightly higher priority than those who have spoken on stage. Okay, yeah. Does that sound about right? So far, so good? about the discussion session. So the next thing I want to show you is a sample question from previous years. So for example, 4 years ago when I taught the graduate level DSP, this is one of the FUD questions. Okay, which reads that I want you to show a proof of a mathematical theorem. Yeah, follow up, because this derivation might be long. Okay, so I want to see if you, so I move it to follow-up discussion, right? I actually give a kind of step-to-step guidance to prove this theorem. So this part A, part B, part C. If you just complete all 3 parts, you complete the proof. So that's one example of an FUD question. And another example is I ask you to some external, I share with you some external reading materials from Wikipedia, and then I ask a question. Okay, so these are like, as I said, maybe mathematically more tricky answers, tricky question to answer. So it's deeper, it requires deeper thinking, more lengthy derivations. For such kind of things, we will move them to FUD. We move them to FUD, right? So the next thing is about homework. The homework will account for 18%, and they will mainly be handwritten problems. And I have a clear goal for when I design the homeworks. Okay, they are designed to help you with the exams. Okay, so they are supposed to help you with the exams. Clear? But that's for the handwritten parts. For some homework sets, we will also give you computer assignments. Okay, but the computer assignment mainly is not asking. We are not going to ask you to write a long computer program, but instead of that, they're not really computer homework. I should say. Most of the problem will involve those computer problems will involve just running MATLAB code. I will share with you a starter code. Just run the code, try to understand the code, and summarize what you observe. Summarize your observation. Okay, what happens to a signal when you listen to them, right? So, not really computer coding homework, but they allow you to familiarize with the MATLAB environment for one thing, and especially for signal processing. So I'm still I promote MATLAB. I love MATLAB. Okay, if that's a bit too strong, I love MATLAB. So I'm not a Python person yet. And so going back to the handwritten part, they will always be openly discussed on Thursday before they are due on Friday. Is that clear? Yeah. We discuss homework on Thursday, and that homework will be due the next day. We'll due the next day, which is the Friday. So that being said, our homework really is not meant to fail you. It will be openly discussed. And if you have if you are too busy with this homework, please just come and listen to others who are willing to share their solution. So I think that's a better kind of spirit to foster within this community, right? We want to be openly sharing our ideas, and we want to not mind that people copy my idea. This is just an undergraduate course, right? So this I've been trying. So the homework really is not meant to fail you, and so therefore we will not be rigorously check plagiarism. 抄袭啊, plagiarism. It's a bit strange, but here I'm claiming that I'm promising to you we will not rigorously check plagiarism. Because it's going to be openly discussed, right? So we just copy the Blackboard solution and write it and submit it. You are going to still get the full score, right? So we're going to actually not going to rigorously check plagiarism, but kind of joking, when you plagiarize, please make sure you plagiarize the right answer. Right, is that clear? But in the meantime, I want to say no late homework is allowed. When we say Fridays 1700, That means what? Friday 1700. Okay? No late homework is allowed because done is better than perfect. In a lot of times, a lot of scenarios, done is better than perfect. And if you really have a hard time finishing part of homework on your own, please seek help earlier rather than later. Send your email, seek help from your classmates, seek help from your TA, send the question to the professor, okay? Start it earlier rather than later, so you have a better chance to present your solution on stage, right? So hopefully this is how things has worked in the past. Hopefully it will also work for this semester, okay? We are not going to rigorously check on plagiarism. It's not encouraged, all right? Please be clear, I do not encourage plagiarism, but I encourage honesty, okay? Let's all be honest about our learning process, our teaching process, okay? So far, so good? Now here's a computer exercise example. Actually, this is your first homework, okay? In the first homework, there going to be this question, which I slightly modified from previous years. You're going to be given a file, a song, actually sung by this group, ABBA, if you know them. You're going to be given an audio clip, 一个音档, audio clip. And I asked you to go through the code and run these few lines, play the sound, and sample the sound, or resample the sound and listen to them, right? So that's a computer exercise. No coding, just to run the code and tell me what you observe, tell me what you hear. So next thing is sort of a summary of all the grading components. So we are going to calculate your raw grade denoted by G, capital G. And here is the combination. First midterm, 20%. Second midterm, 25%. Final exam, 30%. Okay? And then we have 6 homework, which in total will account for 18. And then there's the Thursday participation for 7 points. That's the breakdown. And for all the exams, you are allowed to bring in an A4 size cheat sheet, and you can write on both sides. Okay? Write on both sides. The key word is to write. Do not print. Okay? Do not use the smallest font and print. Handwriting only. Is that clear? Yeah. Cheat sheet, A4, double side. You are allowed to write as much as you want. And next point, your final letter grade. So after we calculate G, but let me just to tell you in advance right now that your final letter will not necessarily be the direct number to letter conversion. Okay? The university has a recommendation, right? What number maps to which letter grade, right? For example, A+ is 90 or above, and so on and so forth. There are like some boundaries, the letter grade boundaries, but we are not going to strictly follow that. Okay? What I can promise that, however, we will preserve the ranking. Okay? We will sort your G, your raw score, 排序, and we will preserve that ranking. That is, a person with a higher G will not get a lower letter grade. Okay, that's a theorem. So that's a rule we'll stick to. Anybody with a higher G will not get a lower letter grade. So that means the grade boundary, 界限, 分数 cut 在哪边, the grade boundaries will be determined by, so we reserve the right to determine those grade boundaries. Is that clear? The boundary hopefully will be lowered, than the university recommendation, because that feels better, right? Is that clear? So, but we preserve the right. In the past, sometimes I need to raise the boundary. People are doing too well, right? And that really hurt in the past. So I'm trying to, I hope that will not happen this year. And typically, I share with you, typically I aim to give A+ to about 10% of the entire class. Last year, maybe they are doing too well. So last year I gave almost 30% A+. They really worked hard. But typically, in my teaching career, I typically give A+ to 10%, maybe 15%. Okay? Last year was sort of an exception. I will need to share with you my findings. So any question regarding the grading policies? Any question regarding the policies? And TA office hour, etc., miscellaneous information. TAs, please say hello with your hand. And we actually have 6 TAs. Okay, so they are going to be in charge of various tasks, and they are mainly to help with your homework and all the gradings. All the gradings are going to be performed by the TAs. And I also asked TA to be available for their TA hours, and they will be announced. And your homework should be submitted through the e-class system. Last year we didn't have any trouble. I believe we didn't have any trouble, and nobody wanted to print it out. Okay, so please just scan your homework, handwritten homework through e-class. Or if you insist, you still prefer paper-based submission, let us know. And for that being said, so if you're an exchange student, if you're from NYCU, you need an account, okay? So please create an account. Ask your TA for help if you need an account. If you need an EE class, that's the system. If you need an account, let your TA know. And X class, I've mentioned that. If you're in the X class, please come to the classroom. Oh, this is important. If you're So if you're in X class, please come to the Thursday sessions because they account for your grades, right? So if you cannot come to a Thursday session, that will hurt. Okay, that really will hurt. And also, let me mention again, you need to attend the exams in person, right? So here's my summary. This course will interest you if you want to learn Fourier analysis and filter design. Then this course will interest you. And this course should also be helpful if you are going to work with time domain signals now or in the future. Okay? If this is a career you're contemplating, this course will help you if your career is about time domain signals. And application fields are plenty, including communication, multimedia, biomed, remote sensing, right? Time domain signals. And hopefully you are going to touch base a little bit, by a little bit of machine learning in the end of semester. And the connection there really is a field called adaptive filtering. Neural networks are adaptive, okay? So adaptive filtering is kind of the bridge toward machine learning in the history. And so we also will cover a bit about information retrieval. I even have a computer homework on that, okay? You're going to be looking at the short-time Fourier transform, a representation of an audio signal, and tell me what's inside. And this slide, just for your information, there are a few related courses in NTHU. To name a few, first of all, there's a graduate level DSP, okay? So for those of you that are fourth-year student, you may want to consider taking this one instead, because it can count toward your master degree. So if you consider using the credit for your math to reduce your load when you become a master student, 硕士的那个抵免了啊。Then you may also want to switch to this course. Professor Zhao and Lin, IEEE Fellow. And another IEEE Fellow, Professor Qinliang Wang, has been offering adaptive signal processing. Okay, that's related. And also we have the field of audio / acoustics. And this is another chair professor from the Mechanical Engineering Department, 动机系, Bai Mingxian老师. Professor Mingxian Bai and myself are in audio or acoustics. And if you're particularly interested in speech, please I highly recommend taking Professor Li Qijun's course. And if you are into video, image, 2D, 3D stuff, again, Professor Chia Wenlin, Professor Chaozong, Huang Caozong, Lin Jiawen. But macro imaging, Professor Li Menglin, or signal processing IC design, you have a course like that. Yeah, so after taking this course, you are ready to combine hardware and software. Please consider taking any course from Professor Huang Yuanhao. All right, so let's take a break. Please come back in 10 minutes.